Welcome to qnawire.
In this question, we have this rod assembly supported by ball and socket joints at A and B. The angular velocity omega is given to be 5 radians per second in the y direction. The alpha is given to be 8 um, along 8 radians per second square along the y-axis. We need to determine the magnitudes of the velocity and acceleration of point C at this instant. Okay, so and we are supposed to use some equations such as E equals to omega cross R, and then we also have acceleration to be equal to alpha cross R plus omega cross R. Okay, we want to use these two equations to determine the magnitudes of velocity and acceleration of point C. Okay, so for point C, we need the position vector for point C. So this is equal to minus 0.4 I plus 0.3 K. So VC is omega cross RC. So this is 5J cross 1/10 minus 4I plus 3K. And solve this, you get 1.5I plus 2K meters per second. Okay, so you can do term by term. For example, J cross minus I, you get K, and J cross K, you get I. Yeah. So the magnitude of the velocity at point C will just be 1.5 square plus 2 square root. And this is equal to 2.5 meters per second. Okay, so this is the magnitude for VC. Okay, then to find acceleration, so we'll be using the equation alpha cross RC plus omega cross RC. So putting in the quantities, so this is 8J cross 1/10 minus 4I plus 3K. And then notice that this is V. Okay, so we put the omega, which is 5J cross with 1.5I plus 2K. Okay, so this is easy to do it term by term, and then the final answer will be 12.4 I minus 4.3 K meters per second square. And then the magnitude of the acceleration at point C will be 12.4 square plus 4.3 square root, and this is 13.1 meters per second square. Okay, so this is the answer for the acceleration at point C, the magnitude.